So today we're going to be looking at periodic trends. You're going to be using your periodic table. You don't really need it because there's going to be pictures. So the first trend we're looking at is atomic radii. So what is atomic radii? It's half the distance between the nuclei of identical atoms that are bonded together. You have two atoms that are chemically bonded. It's the halfway point between them. It increases as we move from right to left across the periodic table. So if you start on the far side and move towards the left, they get bigger. It also increases as we move down a group. So you can see that the biggest stuff is in the bottom left and the smallest is in the top right. What has the largest radius? Lithium, oxygen, carbon, or fluorine? So let's look. Lithium is here. Then we have oxygen over here. So oxygen is smaller than lithium. We have carbon, it's here, it's kind of in the middle, so lithium is still the biggest. And then we have fluorine, which is here. So of those, lithium is going to be the biggest. Now, which is the smallest of the same list? If you're going to look, we go all the way to the right, fluorine is the smallest. That's all you do, you just look at the chart and figure it and decide which ones are smaller. All right, now we're going to talk about ionization energy. That's the energy required to remove an electron from an atom. So if we're removing the electron, you can see that the greater the ionization energy, the harder it is to remove the electron. The energy required increases as you take more electrons away. So the more you want to remove, the harder it gets. So it increases across the period. So as we move from left to right, it increases, and increases as we move up. All right, so the greatest is going to be over in the right top corner, and then the lowest is down here in the bottom left. So consider two main group elements, A and B. A has a first ionization energy of 419. Element B has a first ionization energy of 1,000 kilojoules. The side of each element is more likely to be in the S or P block. So remember the S is over here, and then the P is over here. So the P are going to be a much greater ionization energy than the S. So if we look, A is the less, so that one is going to be in the S block. Well, B has a really great one, great ionization energy, so that'll be the P. Electron affinity is the energy change when an electron is picked up by a neutral atom. So how much energy does it change when it picks up one? Most atoms release energy when they require an electron. Typically, it increases as we move from left to right. And it increases as we move up. So once again, the biggest one is going to be the top right corner, while the least amount is the bottom left. Now we're going to look at ionic radii. This is the radius of an ion, it depends on where it's picked up or lost an electron. If it loses an electron, you would expect it to get smaller. And what will happen if an electron is gained? You assume it gets bigger. So that's right. It gets smaller if an atom loses an electron, but larger if it gains. All right, last one, electronegativity. This is the ability of an atom in a chemical compound to attract electrons from other atoms. So this is wanting to pull electrons in. How well does it do it? The value of most electronegativity is arbitrarily assigned a 4.4, and everything else, the value of the most electronegative element was arbitrarily assigned a 4, and everything else is related to that. It increases as we move up a group and move up, so it goes up, and from left to right across the period. But notice that our noble gases there at the end have a 0 and negative electronegativity. That's because they don't want to attract electrons. They already have a full shell. All right, so which of the following has the greatest electronegativity? Gallium, bromine, or calcium? So if we look, gallium is kind of here in the middle. It's a purple color. And then we have bromine, that's here with the blue. And then we have calcium way over here in the pink. So as you can see, they've increased across. As they moved right, they became bigger. So bromine is the one that has the highest. There is an assignment posted for you to do of this. It's in TeacherMade, where you're going to be looking at similar periodic tables and reading which element is affected by it. If you have any questions, let me know.